One of the things that we said is supported by both DLRs and edge service gateways is dynamic routing. And so in this nugget, we're going to look at how does dynamic routing fit into NSX routing. I have this tendency to kind of personify network devices. It helps me to relate to them if I can think of them as living, breathing things rather than just cold chunks of metal, or in our case, virtualized metal. The fact is, when we first install our routers, they're pretty stodgy little devices. They're wallflowers. They're just sitting there with some interfaces connected to some networks, and the only tool at their disposal is a local routing table, and the only thing that's going to populate that routing table is a list of interfaces and the networks that they're connected to. So in other words, if a router is connected to a particular network, like 192.168.3.0, and it's connected to another network, like 10.0.0.4, well, then the router's going to be able to route between those networks simply by virtue of having interfaces plugged into those networks. But if there's some other router out there with a connection to an interface like 172.16.3.0, this first router, we'll call it router A, has no idea how to get to that particular network. It's never heard of that network. It's not plugged into that network, so it has to be told about that network. And in order to tell it about that network, we could put on our pointy-headed hat and start putting in static entries, identifying each and every network that we might want to be able to forward a message to and identifying the router that's going to handle that. And I'll tell you, sometimes that's a great answer. For example, when we're setting up a default gateway. A default gateway, or a route of last resort, is really just a simple static route that says, if it's not local, kick it to this next router. And that's pretty cool. But really, when a default gateway is insufficient, the technique that most network administrators like to use is making our routers chatty, enabling them to start communicating with one another about the networks that they know. This is an example of control plane communication. It's not about forwarding user packets, it's about informing the other routers about what networks it's possible to forward data packets to. And when we're done, the routing table will have a new population of routing entries that are based upon a dynamic routing protocol. There's a pretty good number of dynamic routing protocols out there, but the two that are supported by NSX are OSPF, Open Shortest Path First protocol, and BGP, the Border Gateway Protocol. OSPF is an example of an interior gateway protocol, whereas BGP is an example of an exterior gateway protocol. And that's relevant because although both are available, what we're typically going to see is OSPF will often be used as a dynamic routing protocol in conjunction with the interior logical routers, the DLRs. Whereas BGP, because BGP is the routing protocol used on the internet, we're typically going to see that only on the edge service gateways. Now you have the control to configure this however you'd like, and as long as you correctly follow the protocol specifications, the end result means that the various routers can be informed about all the various networks. And this is one of those really critical things to understand. NSX is all about rapid deployment, right? And that means rapid deployment of all the VMs and being able to rapidly deploy the networks that those VMs are associated with, and being able to make sure that those VMs can route to each other, but then also making sure that these new networks that are rapidly deployed can easily be routed to or route out and back to other networks. Often, maybe we're just talking about the internet, or we could be working in conjunction with cloud networks as well. So we don't want to lose sight of how important it is to have out and back controls, and the best way to get our routers smarter, faster, is going to be through dynamic routing protocols. So when we get to actually deploying OSPF and BGP, I want you to keep this in mind. These are going to be critical settings that ensure that you don't build a network that's just an island all by itself with no association with anything else in your topology. I hope this has been informative for you, and I'd like to thank you for viewing.